Welcome back. This is a typical ice cream vendor problem that gets done as a project in economics. So what we are doing is we are plotting cost, revenue, and therefore profit functions graphically with the for the given problem. Okay. So what is a given problem? For the given problem, it is the definition is given over in the body over here. Right. There is an ice cream vendor who, if he sells at $3, he is able to sell 120 cones. Okay, if he sells at $3, he is able to sell 120 cones. And if he reduces, the ice cream price by dollar, he is able to sell 200 cones. 80 more cones he is able to sell for a dollar decrease. And then, he incurs 50 cents per cone as a variable cost. Okay, and he also needs to give $100 per day as an entry fee for Central Park. Okay, now for this is a typical problem which gets done as a project in economics. Let's look at it. So what is the given data? Given data is when he's selling at $3, he is able to sell 120 cones. When he's selling at $2, he is able to sell 200 cones. Okay, the difference is 80 cones. Okay, now with this, how what we can infer? What we can infer is we just need to extrapolate linearly. The assumption is the demand varies linearly with the price. So difference for $3 to $2, 80 was a difference, right? For $1, if you extrapolate, it becomes 280. And if he makes it $0, again you extrapolate 360, right? And then on the other side, right, on the other side, more than $3, $4, it will be 120 minus 80, 40, and for 4.5, it will be 0. Okay, big assumption is it is linear. So the equations that we get is n is equal to 360 minus 80 into p, right? 360 from where we got 360 is the value for zero price. Okay, zero price minus 80 is the slope of the demand graph into p price. Okay, so this is how we get it. Now the same thing is n equal to 360 minus 80p, or equivalently p, if you take 360 goes on this side, if you divide by 80, it is 4.5, and then it becomes another fraction is n by 80. Okay, 80 you would have divided. You can do it on a paper. So the revenue function is defined as n star p, this multiplied by p. Okay, if you multiply these two, you get this equation. Cost we know, right? 100 is a fixed cost plus variable cost is 0.5, and if we multiply number of cones sold, it is 0.5 into n into 100. Now this is a typical thing, we need to put it in a Python definitions. If we would do it, it is exactly revenue function is 4 star 5 into n, and then n square, right? N square by 80, that is this function over here. Cost is units sold, that is 0.5 into units sold plus 100. Okay, and how do we calculate profit? Profit is revenue minus cost. Okay, profit is revenue minus cost. So yeah, how we are doing is we are plotting for unit values 0 till 350. Ideally we should have gone till wait a minute here, yeah, more, but I'm just putting till 350. And what we are doing is revenue, cost, and profits we are calculating until we are creating and then printing it. And then just for I equal to x till unit values. Okay, unit values is 0 till 349. You calculate revenue, cost, profit, and then plot them. Okay, plotting them, and plot that legend, revenue, cost, profit, and plot that show. Okay, so this is a standard program problem definition taken from Gregory V. Bart's book, but Professor Gregory has done it using Sage. We are doing it using simple matplotlib and math functions. Okay, math libraries, matplotlib and math library. Okay, now let's run this. See, this is a standard revenue, cost, profit functions plotted against number of console. So you can analyze it during your spare time. I'm just giving this program in the resources section. Thank you.